In this lesson, we're going to talk about summation notation. The first thing that I want you to notice is that we're using a Greek letter, and whether or not you've seen this Greek letter before, it's kind of hard to draw, especially for me as not an artsy type, but the letter is sigma, S-I-G-M-A. It's a capital Greek letter that's actually equivalent to the Greek letter S. The lowercase version of that, which we will use later, and I've made quite a mess of that, we'll use later in the course the lowercase version of that, which is really an O with this sort of straight line sort of sticking out from it. So both of these are sigma. This is the uppercase or the capital letter, and this is the lowercase. We use sigma notation as a short form so that we don't have to write out a whole bunch of stuff. It saves us from having to write, a whole bunch of equations, especially if it's a long summation and we're adding a whole bunch of things together. So summation obviously means sum. We're just adding up a whole bunch of things. And the way that we read our information that we're given here is the first part of it is the formula. The k squared times k minus 3 is just something that we're going to sub our different values into, and we're going to keep getting different answers for each value of k that we put in. The way that we know which values of k that we're going to use is we look here and we look here, so on the bottom and the top of our summation sign. In this particular case, it says that we're going to start at 1 for k, and we're going to go up in whole numbers all the way up to 4. So in other words, our k values are going to be k equals 1, k equals 2, k equals 3, and k equals 4. So normally we would have had to write that out 4 times and then put a plus, plus, plus in between as we went along. The summation notation lets us write it nice and concisely as just this sort of set of symbols, and that's what it tells us in long form. So in order to evaluate this, in order to actually get an answer for it, we do have to write it out in long form. So if you're asked to evaluate or expand the expression, then we would write 1 squared times 1 minus 3 plus 2 squared times 2 minus 3 plus 3 squared times 3 minus 3, that one's going to equal 0, plus 4 squared times 4 minus 3. And if you evaluate all of those, then you're going to end up with 4 numbers that we can later add together to get the value for the sum, which in this case is going to be a sum of 22. And that's how that works. Now, further along in the content, which you're going to be having a look at in a minute in the course content section, there's a couple of more examples. The first one is k squared times k minus 3, so the same expression as what we just worked with, but this time they've changed the lower and the upper limits of the summation. So this time we would start with minus 1 all squared times minus 1 times minus 3 plus, and you're going to add up all of your values all the way up to the final value being 7 squared times 7 minus 3. You're going to add all those answers up, and that will give you the sum. So for something like this one, which is a little bit different, we've got n equals 3 up to 100. And you notice we've switched from k to n, and usually what we see is letters from the middle of the alphabet, like k or n or m there. And so that means that we've got a whole bunch of different values between 3 and 100. We're going to have 97 values to sub in. So generally, they wouldn't ask you to do 97 different calculations and then add them together. There's probably some kind of a pattern or trick that we're going to notice as we get started. So we would start by writing the sine of 3 pi plus the sine of 4 pi plus dot, 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 and all the way up to the sine of 100 pi. So if we stop for a minute and we try to figure out the sine of 3 pi, that's the sine of 180 degrees, or equivalent to that. So if you think about the sine graph or the cast rule or the unit circle, however you find the sine of an angle, the sine of 180 degrees is 0. Now, the sine of 4 pi is equivalent to the sine of 2 pi, and that's the sine of 0 degrees again. And if you think again about the sine graph, which is this kind of a curve, then at 0 we also have a value of 0 for the sine. So the pattern's becoming pretty clear, and you can see that as we go up, we're always going to be adding 0 all the way up to sine of 100 pi. And so overall, the sum of all of those values is just going to be equivalent to 0. So the very last one it looks a little bit different because of the way that they've given us the parameters. It says m is equal to n minus 3, and we're going to go all the way up to n plus 2. And m is the expression, at least they kept that simple for us. And so we're going to start by, instead of writing m, we're going to write n minus 3. And then we're going to work our way up, n minus 2, n minus 1, n plus 1, and n plus 2. And now what we're going to do is we're going to add up all of our n's, 1, 2, 3, 4, 5, 6 of those n's, like terms, and then all of our constants, minus 3, minus 2 is minus 5, minus 6, minus 5, minus 3. And so this whole expression ends up coming out to a pretty simple binomial, 6n minus 3. Now what I would like for you to do is read through the content of the Activity 2 summation notation. And I've worked through the first example with you. There are a couple of other examples there. When you feel like you understand the summation notation idea, there is an assignment that you're going to work on, and the link will be provided in the calendar on the homepage for our D2L course. When you've completed that assignment, you're going to go to the quiz based on that assignment, and you're going to answer some multiple choice questions that are going to be identical to the assignment questions. It won't be every question, but it will be questions directly from that assignment, and the answers will be multiple choice. So have your assignment with you when you're working on that quiz.